So this is an electrode potential question. There's one sheet here, and then there's going to be another sheet coming up in a second. And the question talks about electrode potentials. It's asking us to label a diagram. Then it's asking us to talk about half cells and direction of electrons. And then it's going to talk about oxidizing ability. So we have a cell here with hydrogen on one side and chlorine going on the other side. So it says, suggest suitable labels for A, B, C and D. And this is for the standard electrode potential of the half Cl2 Cl minus half cell. So A is going to be the platinum electrode. B, because it's the standard electrode potential measuring, in beaker B we have H+. And the important thing to write is it's aqueous. C is the thing we use to measure the volts, which is the voltmeter. And D is a gas coming in, so it's either going to be Cl- or Cl2. Cl- is an ion, it doesn't exist unless you put it in solution. So the gas coming in must be Cl2. And then we need to make sure that we know that it's a gas, so we put G. The question goes on to say that half-cell reactions involved are shown below. Use an arrow to show the direction of the flow of electrons in the diagram of the apparatus. Explain your answer. So we've got two different half cells here, and we need to work out which one goes forward, which one gets oxidized, and which one gets reduced, and which one goes backwards. So the most positive reaction goes forwards. So which of these two E0 values is most positive? It's this one. It's the one for half Cl2 plus E minus goes to Cl minus. So that reaction goes in this direction. So if that reaction goes in that direction, reduction, this reaction goes in that direction. It goes from right to left because that is smaller than that. The most positive E0 value goes forwards. So that means that the electrons go from H2, into E minus plus H plus, because this reaction should really be, if we rewrite it to make sense, it's half H2 goes to H plus plus E minus. So this part of the half cell loses electrons. So that means they go from the hydrogen side to the chloride side. And the reason for that is because the reaction that happens overall is half Cl2 plus E minus goes to Cl minus. The second part of the question asks us to relate the E0 values to the oxidizing ability of chloride containing species. So it says the half cell for ClO3 minus half Cl2 is shown below, and we're given an E0 value for that. What does this tell you about the oxidizing ability of ClO3 compared to Cl2? Now, to answer this kind of question, you're probably thinking, well, we haven't got the numbers. If you go back to the first page, we're told what the E0 value for half Cl2 going to Cl minus is. So I'm going to write that down again to remind me. Cf compared with half Cl2 plus E minus goes to Cl minus, and the E0 from that we've worked out from the previous part of the question is 1.36 volts. So if we compare these two numbers, what can we say? Well, 1.47 is bigger than 1.36. So that means the ClO3 gains electrons more easily than Cl2. And that's because 1.47 is bigger than 1.36, which means the ClO3 wants electrons more than Cl2. And the thing that gains electrons is the oxidizing agent. It gets reduced in the process, but the thing that gains electrons is the oxidizing agent. So that means the ClO3 is the stronger oxidizing agent. And we tie that up by saying, because the E0 of the ClO3 half cell is greater than the E0 of the Cl2 half cell.